Before I jump into this video, I am going to say I am surprised. Nobody has completed the equations I gave in the last video, and therefore, nobody has won free money. So I am cranking things up a bit. There will now be a first prize and second prize winner. First prize, however, will not get $5, but instead $10. Second prize gets the now boring $5. But hey, money is money, so jump to my old video right now if you are interested. Make sure to watch the whole video or else you will not understand how the giveaway works. Now, let us jump into the video. I hope you are all ready to learn new things. Well, hello my fellow friends. My name is Mr. Wong. I am how to teach you today. I am a teacher you KRS, section 1.2. Today we talk about the Mathematica modders. We're not talking about the kind of modders you find on the runway. We are talking about sexy math. A Mathematica modder is something that is used to describe real-world phenomenon. Population, the stock market, COVID cases, all these things can be graphed by equations. For example, if we take a look at Aphmau's subscriber count over the years, we can model this as a graph and learn a few things from this data. Here is a graph depicting said information. Wow, just like my graph depicting the amount of dog eaten over time. This one also has a recent spike. That is epic. 4 million new subscribers in 1 year. I personally do not watch this YouTube channel, but I assume this growth may be directly due to COVID-19. This is because her insane growth began approximately 8 months ago. Around this time, a decent amount of people also began staying home. So I guess what we can learn from this data is that now is a good time to be a YouTuber. Now you may be asking, why is Mr. Wong talking about this? How is this relevant to math? Well, the message here is that Mathematica modders read to Mathematica conclusions. My conclusion here was to correlate the current pandemic with YouTuber success. But it may be attributed to many other things. Maybe her content changed. Maybe she beat the YouTube algorithm somehow. If you think you know the real reason for this great success, please let me know in the comments below. I am quite curious. Now, Mathematica conclusions can read to real-world predictions, and by now hopefully you are starting to see the big picture here. We can use math to model things in the real world, use math to interpret this data, and then make predictions about things. That is exactly what I did with Aphmau's subscriber count. My prediction here was that if I start a YouTube channel now, I will have a good chance for success. Only time will tell me if my prediction is right, or if this university will be burnt to the ground and forgotten. On a tragic note, we are now about to talk about different types of Mathematica modders. There are 8 types, so grab your popcorn and take a seat. We are just getting started. The first is the linear modder, the most simple and basic type. Yup, it's just line, nothing special about it. Many people are familiar with this modder and its function too. Y equals mx plus b. Mostly because every math teacher ever has spammed everyone with this equation. But we are talking about quote-unquote real-world data here. Everyone here knows data does not usually show up as a nice linear modder in the real world. This is where empirical modders come in. This is when we make a straight line that hits as many points on the graph as possible. Therefore, we may have a simple function that represents the graph that we may analyze easier. The next topic is polynomials. Most people hate these because they can be confusing and annoying to work with. But everyone can agree that they make the best graphs. Look, here we have a smile and here we have a frown. So cool. Okay, I am going to show you what defines a function as a polynomial. I am warning you, it is not pretty. This is for brave math boys only. I am going to show it. Oh, the horror. It is so complicated. Whatever shall I do? Psych. I break it down for you. Here we said p of x because p stands for polynomial here. Now here there is an a and a letter n. It is so tiny, how cute. This letter n is a subnotation. It means that it is the coefficient for this degree. We multiply sub n by x to the power of n because, why not? The important thing to take away from this definition is that we add up each one of these terms, and that each term has a degree of 1 less than the previous degree. So a polynomial R with a degree of 6 where it composed of x to the power of 6 plus x to the power of 5, 4, 3, 2, 1, 0, boom. JK. Now you might be thinking I don't see no 5, 2, or 1 in your example, Mr. Wong. Are you blind, Mr. Wong? Do you have schizophrenia? Well, my dear student, to that I say, no Coroner Sanders, you're wrong. All these things are here, except the invisible parts have their coefficients as 0. The degree of the polynomial also determines the shape of the graph. Here is graph of a polynomial R with a degree of 2, also known as a quadratic function. And here is a graph of a polynomial R with a of 3, also known as a cubic function. Next we have power functions. These functions are simply x to the power of any positive number. Generally, these have the same shape depending on whether the number is even or odd. If this number is a fraction, however, we are now dealing with a root function. There are also reciprocal functions which are power functions with negative exponents. These are the exact same things you see when graphing 1 over x. Yes, that is because our fractions are negative exponents. No wonder why nobody likes them, they're just so negative. Speaking of fractions, that brings us to our next type of function. Rational functions. This is a function where we divide a polynomial by another polynomial. They are literally not important right now, so I will go to the next one. Next we have algebraic functions. These are made by using any algebraic operation you can think of. Simple things like adding, subtracting, multiplying, dividing, and square roots. Personally, I like x times the square root of x plus 3 because it makes a just do it. And then there are trigonometric functions. Sorry if you don't like trigonometry, but it goes hand in hand with calculus, so deal with it. These functions come up when we use sine, cosine, tangent, or any other weird trig function. All they do is make a bunch of squiggers. Infinitary. We are almost done, do not worry. If you want to keep running, do not forget to like and subscribe. This will our important to make new content and dive deeper into your favorite math subjects. Finale, we have the exponential and logarithmic functions. Exponential functions graph how many brain cells I rose watching Jake Paul. Instead of putting x to the power of a number, we put a number to the power of x. Brilliant. Thank you, math. Logarithmic functions take the logarithm of x. Bet you did not see that one coming. If you don't know what logs are, go outside. Just kidding. Our log means is, we take the small number and figure out what power we must raise it to get x. Log base 2 of 4 is 2. Log base 2 of 8 is 3. Because 2 to the power of 2 is 4 and 2 to the power of 3 is 8. Aphmau. That is everything. I will admit I dragged this lesson out a bit, the material was quite uneventful. But do not worry, the next 3 videos will also be uneventful. But I promise by the time we get to chapter 2 you will feel your brain swelling up with knowledge. But that is it for this video. So without further ado, I see you the next time. Always remember, Mr. Wong love you very much. He be arrive in a YouTube. Bye bye.